Assalamualaikum and a very good morning to our lecturer, Dr. Syarah binti Kasim, for subject KIM3003, Amali Kimia Organic dan Analysis. We are from Group 7. We would like to present our group assignment, Experiment 8, entitled Acid-Base Titration. I will introduce to you our group members, NURDYANY ASYRANY binti Muhammad RUDDY, CHONG ZHENG, NADIRA AMIRAH binti MOKHTAR, MUNAWWARAH binti AZHAR, SAFIA ALEESA binti Muhammad FAHMI, and one Muhammad MUSYRIF bin one MUSTAFA. Objective for this experiment. The purpose of the experiment is to enable students to properly demonstrate acid-base titration by using the right indicators and to calculate the concentration of base solution via acid-base titration. Next is introduction. The reaction between acid, hydrochloric acid, and base, sodium hydroxide, known as neutralization reaction. Chemical reaction involved is as below. Hydrochloric acid in aqueous plus sodium hydroxide in aqueous form sodium chloride in aqueous plus water. Ionic equation is H plus in aqueous plus OH minus in aqueous form water. The equation for this reaction can be used to determine the concentration of acid or base using titration method. In the titration process, base solution added from burette into Erlenmeyer flask containing acid with a known concentration. Base is added to the solution in Erlenmeyer flask until equal number of OH minus and H plus mole is reached.
The apparatus used in acid-base titration is burette, pipette, Erlenmeyer flask, retort stand, volumetric flask, and beaker. Chemical use is phenolphthalein indicator, 1.0 mole of sodium hydroxide and 0.1 mole of hydrochloric acid. Technique and methodology. First, pipette 10 cm³ of hydrochloric acid solution into a 250 cm³ Erlenmeyer flask. Second, add 25 cm³ of distilled water and 2 to 3 drops of phenolphthalein indicator. Then, pipette 5 cm³ of sodium hydroxide solution into 100 cm³ volumetric flask and dilute further with distilled water up the mark. Next, titrate acid solution in step 2 with sodium hydroxide solution until the solution turns pink. Titrate slowly and with care when approaching the final point. Lastly, repeat titration twice. Record the result.
For the expected results, initial reading is the starting volume of sodium hydroxide before titration, while final reading is the volume of sodium hydroxide when the solution turns pink. Both are used to calculate the volume used by subtracting the final reading and the initial reading. For trial 1, the initial reading is 18.5 ml and the final reading is 8.6 ml. Therefore, the volume used is 9.9 ml. For trial 2, the initial reading is 25.5 ml and the final reading is 40 ml. The volume used is 11.5 ml. Lastly, for trial 3, initial reading is 33 ml and the final reading is 21.4 ml. The volume used is 11.6 ml. The observation for 3 trials are the colors of solution changes from colorless to pink. Next, calculation of concentration of base solution used. First, we need to calculate the average volume of base, which is the sodium hydroxide. We need to add the volume used in all 3 trials and divide it by 3. Therefore, we will get 11 ml. Then, we need to write the balance equation of the titration, which is hydrochloric acid in aqueous plus sodium hydroxide in aqueous, and we will get sodium chloride in aqueous and water. To calculate volume of acid, which is the hydrochloric acid, we need to change the volume from milliliter to liter. So, 10 milliliter is divided by 1000 and we will get 0.01 liter. Do the same thing for the volume of base, the sodium hydroxide, using the average volume. So, 11 milliliter is divided by 1000 and equals to 0.011 liter. Finally, we use the formula MAVA equals to MBVB to find the concentration of sodium hydroxide, which is the MB. Therefore, we need to substitute MA to 0.1, VA to 0.01, and VB to 0.011, and we will get MB equals to 0.0909 molar. So, the concentration of base used is 0.0909 molar.
As for discussion, there are multiple questions asked. Number 1, why does the number of hydrogen ion moles must equal to the number of hydroxide ion mole at the end of titration? This is to make sure the neutralization can occur. This is because equivalence point is the point where concentration of hydrogen ion is equal to the concentration of hydroxide ions. The second question is, why does phenolphthalein indicator used in this experiment? The answer is phenolphthalein is used to test the pH of the solution. Phenolphthalein indicator is chosen because it can change color in a pH range between 8.3 to 10. It will appear pink in basic solution and clear in acidic solution. The next question is, what is other indicator that more suitable to be used in this experiment? The answer is methyl orange indicator. This is because it's clear and distinct color variance at different pH value. Methyl orange show red color in acidic solution and yellow in basic solution. The next question is, what is primary standard solution and secondary standard solution? Give one example for each. As for primary standard solution is a pure reagent that are typically used to determine an unknown concentration. This is also often used to make standard solution with a precisely known concentration. The example for primary standard solution is sodium chloride, NaCl. As for secondary standard solution are the solutions that are analyzed against a primary standard. Usually, these solutions are prepared in laboratory for use in a specific analysis. The example for secondary standard solution is sodium hydroxide, NaOH.
Question number 5. Boiling point for hydrochloric acid HCl and carbon dioxide CO2 is almost the same, negative 85 degrees Celsius and negative 78 degrees Celsius respectively. Why does CO2 can escape from the aqueous solution through heating, while there are no occurrences of loss of HCl upon heating for 1 hour or more? Explain your answer. So for the first one is, the boiling of any species is inversely related to its vapor pressure, which means that the higher the vapor pressure, the lower will be the boiling point. Next, carbon dioxide and hydrochloric acid do not vaporize at the same rate even though the boiling point are nearly the same. This is because the carbon dioxide is not strongly bonded to H2O molecules, so they volatilizes from the aqueous media in a short period of time. On the other hand, hydrochloric acid molecule in water ionize completely to produce H3O+ and Cl-, which are non-volatile. Thus, by boiling HCl for an hour or more, no appreciable amount of hydrochloric acid is lost. Next, question number 6. Volume of water added during the experiment to wash drop of acid from the burette or volume of water added to the acid in the LMAO flask do not affect the calculation and can be ignored. Why? So, it will not affect the calculation and can be ignored because the volume might be changes, but it will not change the amount of substances inside, neither the initial volume. When the water was added, the concentration of the analyte will still be unknown. Water does not react with the reagent or change the number of moles of acid added. Question number 7. Suggest 2 safety precautions to be taken when doing this experiment. The first one is wearing protective equipment such as gloves, goggles, and lab coat during the experiment. The second one is to titrate the solution drop by drop to ensure the accuracy of the result, as it may change within the addition of amounts as small as 2 drops.
For the discussion number 8, explain 3 factors that might cause the experimental result not meet the practical theory. So the answer is first, misreading volumes, not looking to the meniscus level when taking the reading. The eye position does not perpendicular to calibration reading of burette cause the measurement in error. Second, incomplete rinsing. transferring of two different solutions using the same pipette without rinsing the pipette with distilled water in between, and third, error in endpoint determination. As the indicator changes color to indicate the reaction has finished, it has been observed carefully to make sure that it does not change instantly to sustain the accuracy. In conclusion, acid-base titration was demonstrated by using the right indicators, which is phenolphthalein indicator. The concentration of the base solution also calculated by using MAVA equals to MBVP formula via acid-base titration experiment. The concentration of base solution is 0.0909 m. That's all from us. Thank you.